Download this code from codegive.com, link in the description below. Tutorial: Discovering logic bugs and access control issues in real-world applications. Introduction. Logic bugs and access control vulnerabilities can lead to severe security issues in web applications. Logic bugs occur when the application does not behave as expected due to flaws in the logic of the application code, while access control vulnerabilities allow unauthorized users to access restricted functionality or data. This tutorial will guide you through understanding common logic bugs and access control issues, and provide you with practical code examples to demonstrate how to discover and exploit these vulnerabilities. Prerequisites. Basic understanding of web applications and how they operate. Familiarity with programming concepts, particularly in languages like JavaScript or Python. Basic knowledge of web security principles. Common logic bugs. 1. Incorrect conditional statements. Logic bugs often arise from incorrect conditional checks that allow unexpected behaviors. 2. Race conditions. Occurs when two processes access shared data and try to change it at the same time. 3. State management issues. Problems with how an application tracks user state can lead to bugs where users can access or manipulate data they shouldn't. Common access control issues. 1. Insecure direct object references, IDOR, when an application exposes a reference, like an ID, to an object in the URL, and users can manipulate it to gain access to other objects. 2. Missing function-level access control, when functions or endpoints are accessible without proper authentication. 3. Broken authentication, when authentication mechanisms are flawed, allowing unauthorized access. Code example: logic bug. Let's consider a simple banking application written in Python. Python. Class bank account. Def __init__, self, owner, balance equals 0. Self.owner equals owner. Self.balance equals balance. Def withdraw, self, amount. If amount self.balance. Print, insufficient funds. Return. Self.balance dash equals amount. Print, f withdrew amount, new balance is self.balance. Example usage. Account equals bank account, Alice, 100. Account.withdraw, 150, correct behavior. Logic bug demonstration. Now, let's introduce a logic bug by allowing negative withdrawals. Python. Def withdraw, self, amount. If amount 0. Print, you cannot withdraw a negative amount. Return. If amount self.balance. Print, insufficient funds. Return. Self.balance dash equals amount. Print, f withdrew amount, new balance is self.balance. Malicious withdraw. Account.withdraw, -50, new behavior, allows negative withdrawal. In this scenario, the logic allows an invalid operation, negative withdrawal, which could lead to abusive behavior if not caught. Code example: access control issue, IDOR. Consider this simple Flask application that exposes a user profile based on user ID. Python. From Flask import Flask, request. App equals Flask, __name__. Users equals 1. Name, Alice, role, admin. 2. Name, Bob, role, user. At approot, /profile/int user_ID. Def profile, user_ID. Return users.get, user_ID, user not found, 200. Start the Flask app. App run. Access Control Vulnerability Demonstration. This application is vulnerable to IDOR. An attacker can change the user ID in the URL to access other users' profiles. Exploitation example. 1. A user with ID 1, Alice, accesses their profile. Get/profile/1. Response, name, Alice, role, admin. 2. The attacker changes the URL to get/profile/2. Response, name, Bob, role, user. Mitigating logic bugs and access control issues. 1. Input validation, always validate user input. For example, in the withdrawal function, ensure the amount is non-negative. 2. Proper access control, implement checks to verify that a user has permission to access the resource. In the Flask app, check the user's role or ownership before returning the profile information. Python. At approot, /profile/int user_id. Def profile, user_id. Assume user_id is the ID of the logged in user. If user_id equals logged_in_user_id. Return access denied, 403. Return users.get, user_id, user not found, 200. 3. Logging and monitoring, implement logging to track access to sensitive endpoints and monitor for unusual activity. Conclusion. Logic bugs and access control issues are common vulnerabilities in web applications. By understanding how they can occur and implementing proper validation and access control mechanisms, you can significantly enhance the security of your applications. Always adhere to secure coding practices and regularly audit your code for potential vulnerabilities. Further reading. OWASP Top 10 Project, https://owasp.org/www-project-top-10. Secure Coding Guidelines, https://www.owasp.org/index.php/secure_coding_guidelines. By following the principles outlined in this tutorial, you can start discovering and resolving logic bugs and access control issues in real-world applications effectively.